Today, we're going to learn one of the important skills in understanding the structure of an atom, how to write electron configuration.
Welcome to my channel, Science with a Touch of Hugot. Let's explore! Discover short stories and discover ourselves.
What is electron configuration? So, electron configuration tells us how the electrons of an atom are arranged in its orbitals. There are steps to follow in writing the electron configuration. Don't worry if this looks complicated. At first, we'll do it step by step. So let's start. Step 1. Know the number of electrons. First, we need to know how many electrons the atom has. For a neutral atom, the number of electrons is equal to the atomic number. And oxygen is found in family 6A, period 2. So, its atomic number is 8. Therefore, its number of electrons is 8. So, a neutral atom of oxygen atom has 8 electrons. Now, our job is to distribute these 8 electrons into the appropriate orbitals. Step 2. Follow the order of filling. The Aufbau Principle tells us that electrons occupy lower energy orbitals before higher energy orbitals. We have a mnemonic device for us to know the order of filling the electrons. And I'm gonna show you how to make the mnemonic device. So, we have to write first 1, 2, 3, 4, 5, 6, 7, going down, and then 2, 3, 4, 5, 6, 7, and then 3, 4, 5, 6, 7, and then 4, 5, 6, 7, and then we will put S in this first column, and then P for the second column, and then D for the third column, and then F for the fourth column. Now, we will draw arrows, diagonal arrows, downwards. Don't simply fill the energy levels one by one. We follow the energy order of the orbitals according to the mnemonic device. Step 3. Know how many electrons each sublevel can hold. So, the S sublevel can hold up to 2 electrons. The P sublevel can hold up to 6 electrons. The D sublevel can hold up to 10 electrons. And the F sublevel can hold up to 14 electrons. So these are the number of electrons of each sublevel can hold. Step 4 is to write the oxygen's electron configuration. And according to the periodic table of elements, oxygen has atomic number of 8. Therefore, its number of electrons is 8. Now, we just need to follow the order of filling in the electron configuration using the mnemonic device. So we will start with 1s. And since S has a maximum of 2 electrons, then our superscript is 2. Next is the 2s. And then, since S again can hold a maximum of 2 electrons, then we use superscript 2. The next is 2p. But what will be our superscript? Now, in here we have to count. We already have 2 plus 2, that is 4. And to have 8, we need 4 more electrons. So we put 4 as the superscript here. So the electron configuration of oxygen is 1s2, 2s2, and 2p4. Step 5 is to check our answer. And in checking, we simply add the superscripts. So our superscripts here are, we have 2 plus 2 plus 4, and that is 8 electrons, which is the total number of electrons for a neutral oxygen atom. What do the numbers and letters mean? For example, we have 1s2. This one here tells us the energy level, meaning these electrons are found in the first energy level. This S here is the sublevel, meaning these electrons are in the S sublevel. And the 2 superscript here is the number of electrons found in the 1s sublevel. Guys, remember the 3 important rules. Rule number 1, Aufbau Principle. Electrons fill the available orbitals starting with the lower energy orbitals before moving to higher energy orbitals. Rule number 2, Pauli Exclusion Principle. An orbital can contain a maximum of 2 electrons and they must have opposite spins. The number 3 rule, which is the Hund's rule. When electrons occupy orbitals of the same energy, they occupy them singly first before pairing. These 3 rules help us determine how electrons are arranged. Writing electron configuration becomes much easier when you remember these steps. First, know the number of electrons. Second, follow the orbital filling order. Third, remember the capacity of each sublevel, which is S is 2, P is 6, D is 10, and F is 14. And finally, apply the Aufbau Principle, Pauli Exclusion Principle, and Hund's rule. At first, it may look like a lot of numbers and letters. But once you understand the pattern, electron configuration is really just about putting electrons in the right places. And remember, just like in life, electrons have their own proper place, and they follow the rules.
Thank you for learning with me today. Remember, biggest classroom. Don't forget to subscribe for more lessons. Keep finding the Hugot in every day. See you in the next lesson.